Good morning, good afternoon, and good evening. This is a presentation that describes how the Web 7.0 DIDComm ARM, the HTTP version of the DIDComm ARM, can be mapped to the TOIP 4-layer hourglass framework. So the agenda, after a few introductory slides, we're simply going to walk through the 7 layers of the Web 7.0 DIDComm ARM architecture reference model, and then using the TOIP 4-layer hourglass framework, show where each of the new elements introduced in each of the subsequent layers shows up in that TOIP hourglass framework. All of this is based on the DIDComm Agent Architecture Reference Model white paper, which was published in mid-December. You can find a link to it on hyperonomy.com. It's the top article that's pinned to the top of that blog. The purpose and goals for the white paper is to act as a guide for software architects and developers building decentralized applications, DIDComm agent-based systems. And the 3 specific goals of the white paper are to better understand the active components of a DIDComm agent-based software system and how they interact and rely upon each other, to introduce a graphical modeling language, the DIDComm notation, to aid architects and developers in visualizing these architectures and designs for decentralized, DIDComm agent-based systems, and to describe a layered approach, the DIDComm ARM, to help design and create, the broadest range of decentralized DIDComm agent-based systems possible. So this particular presentation actually supports all 3 of those goals. So the layers, if you've looked at any of the DIDComm ARM video tutorials on YouTube, you'll be familiar with these layers. I'm going to walk through them visually. So this is a visual depiction of the DIDComm ARM model, and you can see the layers. There we have layer 0, which is really the simplest, most simple baseline technology architecture that developers are most likely to know, and that's a simple REST over HTTP agent. Not using DID addressability, not using DIDComm messaging, and we start out there with a simple example. From there, we just add DID addressability. So we're just using REST over HTTP agents, but we're using DIDs to address those agents, to name those agents. And of course, this is where we introduce the DID registry, because to be able to send a message, a REST over HTTP message from one agent to another, you need to be able to take the receiver's DID and look up their service endpoint. So this is just addressability. We're not doing any authenticated encryption. This is simple REST over HTTP messages. The authenticated encryption is introduced in layer 2, where we take a tiny baby step from layer 1 to layer 2, and we introduce DIDComm messaging on top of the layer 1 and layer 0 models. So we're still using REST over HTTP as the transport. We are using DID addressability to locate the service endpoint, to resolve the service endpoint for the DIDComm agent. But now the sender and the receiver DIDComm agents are using authenticated encryption to prepare those messages. We refer to that as outbound processing, and of course inbound processing is the name we give to the decryption and authentication of those messages. Layer 3, again, a tiny baby step from layer 2. Layer 3 just adds the ability to have attachments to your DIDComm messages. So for example, this could be a purchase order, an invoice, a waybill, a delivery confirmation attached to a DIDComm message, potentially a custom DIDComm message. And those are the four core layers, the four core capabilities that developers need to. Layer 4 takes things in a significantly different direction, and this is where we envision a mesh network that connects a large number of DIDComm agents together. And so we have intelligent routing of DIDComm messages, secure private intelligent routing of messages through the DIDComm network, support for disconnected clients, clients that are either offline or clients that are agents that are behind a firewall. Layer 5 illustrates the idea of specialization of a DIDComm agent. So a particular type of DIDComm agent is a DIDComm user agent. This is an agent that has a user interface, a user experience, an app, if you will, a DIDComm app that enables people and frogs on the outside of the network to be able to interact with each other, to be able to interact with the network. The seventh layer, layer 6, is the Web 7.0 architectural model, and this is where we flesh out the entire platform and add a number of key components in terms of fit and finish. This is a picture of the TOIP technical architecture specification hourglass framework. We see that on the left. This is something that Daniel Hardman had worked on, and it's part of the trust spanning layer, trust spanning protocol initiatives within TOIP. And what I've done is take those 4 layers of the framework, of the hourglass framework, and on the right-hand side, I've annotated it with the Web 7.0 DIDComm HTTP profile. And so this is taking all the active elements, the individual elements of the DIDComm communications suite, and map them to the respective layer in the hourglass profile. So what we're going to do is actually walk now through each of the 7 layers of the Web 7.0 DIDComm ARM, and we're going to highlight which of these elements on the right are used to support or used to implement that particular layer of the Web 7.0 architecture reference model. So let's start with layer 0, which is the REST over HTTP agent model. So here in the REST over HTTP agent model, we're just talking about a sender on the right, either an agent or a client, wanting to send just a plain text message to the agent, the receiving agent on the left. So very simple, minimum requirements. And of course, if we look at the framework, we can see that we just require REST over HTTP protocol support at the bottom, one of the foundational layers, one of the foundational elements of layer 1. If we go up a layer to layer 1 in the Web 7.0 DIDComm ARM, we're now talking about adding DID addressability. We're still doing plain old REST over HTTP communications between a sender agent or a sender client and a receiving agent. And so here's how we depict that. So the blue line there it's still just REST over HTTP. It's still a plain text message. We have Alice on the right, Bob on the left. Alice has a personification in terms of Alice being a person. She represents the sender, a subject within this example. And on the left we have Bob. Bob has his personification on the far left, and Bob as well as Alice both have a software agent that are capable of representing them or acting on their behalf. And the way that we support DID addressability for REST over HTTP agents is illustrated here with the introduction of the DID registry. And so for Alice's agent to be able to send the message to Bob's agent, Alice needs to know the address of the service endpoint for Bob. Not for Bob, but for Bob's agent. And so Alice's client or Alice's agent takes Bob's DID, the DID person 5678, sends it into the registry. The registry says, aha, I have a DID document for you, and returns it. And then what Alice's client is going to do is extract from that DID document the service endpoint for Bob. And we see that illustrated by the green line. And then Alice is simply going to create an instance of an HTTP client and execute an HTTP put against that service endpoint URL for Bob. In this particular example, that service endpoint URL is http://example.com:8080. That resolves to the numerical address via DNS at 93.184.216.34:8080. So in terms of mapping this TOIP hourglass framework, all we need is addressability. We need a DID registry, and in Web 7.0 we need a DID registry gateway client, a gateway agent. The reason for that third element is everything in Web 7.0 runs on the DIDComm protocol. So the role of the DID registry gateway agent is to provide a DIDComm interface over top of whatever the DID resolution protocol is that's supported by the DID registry. At the bottom, you can see the rest over HTTP appears in black, but is not bolded. It just means that we inherited that from the previous layer, layer 1 of the model. Okay, layer 2 builds on layer 0 and layer 1 to support DIDComm messaging. And we see that illustrated here. So as we move from layer 1, right one step, one baby step from layer 1 to layer 2, all we're doing is taking that REST over HTTP model and DID addressability from layer 0 and layer 1 and adding messaging. So we see that illustrated here in its most simple form. We've got a client on the right, a sender, who wants to send a DIDComm message, an authenticated encrypted message from the sender on the right to the receiver on the left. We notice the purple boxes there. So on the client, that arrow that represents an origin interface, that's an outbound interface. That's where that client emits messages, DIDComm messages. And the purple box is referred to as outbound processing, and that's where the authenticated encryption occurs. On receipt by the DIDComm agent, the DIDComm agent receiver on the left, you see another purple box on the service endpoint, the interface that has the ball or the bullet on it, and that's where the decryption and authentication of the sender occurs. We have those labeled clearly on. We have these labeled a little more clearly on this model: outbound processing and inbound processing. And of course, we just use what we've learned from layer 0 and layer 1. Layer 0 says we're just going to use the REST over HTTP. Layer 1 says we're going to use a DID addressability, so we have a DID registry, the same DID registry that we had before. David's Cabbages, in this case, has a DID of DID:org:111222333. ABC Grocery is going to look that up in the DID registry to get David's Cabbages DID document. From that, ABC Grocery's agent is going to extract the service endpoint for David's Cabbages and send that authenticated encrypted message from the right to the left. Outbound processing is going to do the authenticated encryption inbound processing on the left. David Cabbage's agent is going to do the decryption and authentication. How does this fit into our? So we can see on this slide that we're just adding DIDComm messaging and DIDComm agents. Previously, we were just dealing with REST. You can see that in black at the bottom. In layer 0 and layer 1, we added the DID addressability in the registry. So there's, in terms of what's incremental in layer 2, it's DIDComm messaging and DIDComm messages. DIDComm custom protocols weren't specifically mentioned in these slides, but if you check into the visual tutorial, the video tutorials on the Web 7.0 DIDComm ARM, you'll learn about that. You can also have custom DIDComm message types. Those are relegated to layer 2. And finally, we've introduced the DIDComm agent, which is a layer 4 construct in the Hourglass framework. Layer 3, so a tiny baby step moving from layer 2 to the right. Layer 3, all we're adding is the ability to attach an attachment to an existing DIDComm message. So we have that illustrated here at the bottom. That's the DIDComm notation for a verifiable credential. In this case, it's a purchase order verifiable credential for 10 cabbages, ABC Groceries wants to order 10 cabbages from David's Cabbages, David's Cabbage Patch. And so it's exactly what we know from layer 2. We have ABC Grocery will create the purchase order. It will create the DIDComm message. It will attach the purchase order to the message. And then you see the purple box on ABC Grocery's software agent, where the encryption and authentication is going to occur. That's going to be sent over to David's Cabbages, and on David's Cabbages inbound service endpoint with the bullet there, that purple box is going to do the decryption and the authentication. In a little more detail, we're just building on level 0 and layer 1 and layer 2 and adding, but here all we're doing is adding the ability to attach a purchase order verifiable credential as a DIDComm message attachment. Everything else that we've learned about layer 0, layer 1, and layer 2 is the same. How does this map then onto the TOIP TAS? This brings us to a discussion of the raw credential sender-receiver model. We have the credential sender DIDComm agent on the right and the credential receiver DIDComm agent on the left. And we'll go through the 7 steps that the sender and the receiver use to both send a DIDComm message that has a credential attachment and as well as receive and process that credential. So if we look at what the credential sender needs to do, there's 3 steps. The sender obviously needs to create the credential. They need to auth encrypt the credential, and then they need to send the credential. And that's step 2, the auth encryption takes place in the purple box there on the origin, the arrow-shaped interface of the credential sender. If we move over to the left, we have the receiver, credential receiver receiving that auth encrypted message on its service endpoint, the round or bullet-shaped inbound interface. And in that purple box, we have 2 steps, steps 5 and step 6, that are processed to decrypt the credential and to verify the credential. Finally, step 7, of course, is just to process the credential based on the particular business process or workflow that's indicated by the incoming credential. So just to dive in a little bit deeper, what is the definition of a raw credential, or what we sometimes refer to in Web 7.0 just simply as a credential? So the following list of 6 terms are equivalent in the Web 7.0 model. So of course the term raw credential, a raw credential is equivalent or synonymous with a collection of properties where one of the properties is an identifier, a collection of attributes alternatively where one of the attributes is an identifier, a collection of name value pairs where one of the pairs is an identifier, a collection of claims where one of the claims is an identifier, or a claim of assertions where one of the assertions is the identifier. So you begin to see the pattern there. An important thing to note is that a raw credential by definition is not a verifiable entity, unless of course the credential has a verifiable proof associated with it. So picking up on that latter part, that latter comment, what is a verifiable credential? So a credential that has a verifiable proof associated with it, plus most likely some additional metadata, the credential is referred to as a verifiable credential. All verifiable credentials are by definition raw credentials. However, only raw credentials with an associated verifiable proof can be referred to as verifiable credentials. It is only if they have the associated verifiable proof that in fact the credential becomes verifiable. Framework. So here we're taking everything that we've learned about before, everything that's in black. The three new things that we've added here, again, is just the simple idea of DIDComm message attachments. So we see that in bold. So there's the DIDComm message attachments in the framework layer 2, custom types in layer 3, and then just the generic sender-receiver model, exactly what I've described on the previous slides. It's generic enough that it belongs in layer 2 of the TOIP hourglass framework. Layer 3, so layer 4, we're getting closer to the end here. Layer 4 builds on the the four foundational or core layers that we've just talked about to support a DIDComm agent mesh network model. We can see that illustrated here. So instead of just doing point-to-point communication between the client or agent on the right and the client or agent on the left, or the agent on the left, as we've seen in the previous layers, we have the ability now to drop that or forward that DIDComm message into the DIDComm network, which is comprised of DIDComm router nodes, which are special DIDComm agents that know how to do intelligent, private secure routing, intelligent private secure routing of DIDComm messages in the most efficient way through the network from the receiver, from the sender to the receiver. And we see that illustrated here. There is the concept of the minimal viable DIDComm network for development purposes, which is just a single node. I've added this here to highlight the disconnected agent scenario where the agent on the left may be offline, the computer or laptop or phone may not be running, and the client wants to send a reliable, resilient DIDComm message over to that disconnected client. And so the idea is that the sender, the client on the right, would forward that to a router node in DIDComm terminology. That would be a mediator or a relay. And then when the agent on the left comes online, it can check that relay node to see if there's any DIDComm messages waiting for it. The other sort of sub-scenario there is where the agent on the left is behind a firewall, and so it's not possible for the client to send an HTTP request, from the outside of the firewall to the inside of the firewall. So the same solution applies. The client, the sender on the right, would post that into the network, into that single relay mediator router node, and whenever periodically the agent on the left would would pull that that relay node to download any messages that might be waiting for it. So what do we need? What do we need to add in terms of the Hourglass framework to realize layer 4? So with layer 4, we add the DIDComm agent mesh network and the DIDComm network router agent. So these are services, these are network services, just like the DID registry and the DID registry agent gateway. It's all enabled by DIDComm. The router agents are all DIDComm agents. And so they're part of the foundation. They're part of layer 1 trust support in the TOIP TAS Hourglass framework. Layer 3. So layer 5, the second last layer. Here what we're doing is adding again a specialization of the DIDComm agent, where a DIDComm user agent is used to expose a user interface or user experience to humans or frogs that are trying to access the DIDComm network. So we can see the DIDComm user agent at the top of the blue box. And so a DIDComm user agent is paired with a traditional DIDComm agent at the bottom of the blue box. And it's the agents in the bottom half of this diagram that exchange DIDComm messages and talk to one another. But whenever the end user needs to to see them, to see perhaps an incoming credential representing a person, wants to see it as a business card, that would be displayed by the user agent. Or in this case, in this scenario here, it could be doctor's notes or x-rays or lab excuse me, or lab results. Those would be displayed by the user agent, but they would be received and stored by the DIDComm agent on the left, bottom left. If we take this specific scenario or and put it in the context of what we've been talking about before in terms of a DIDComm notation architecture reference model, we can see the DIDComm agent is at the top there and how it's paired with the DIDComm agent. As messages are sent from the sender, in this case the DIDComm client on the right, and routed through the network and received by the DIDComm agent on the left, those are available to be displayed in the DIDComm user agent. And just to the right of the DIDComm user agent, we see a mock-up of a little chat application where text messages can be sent and received, as well as verifiable credentials. And we see a little colorful rectangle there representing a business card from a schema.org contact or schema.org person that was received from another person on the DIDComm network. Okay, so where do user agents figure in? Well, simple addition at the layer 4 trust applications. It's a specialization of the DIDComm agents from layer 2 in the Web 7.0 model. And so we see that highlighted there in bold. Layer 3. So, well, the last and final, the 7th layer is the layer 6 Web 7.0 architectural model. Remind ourselves what Web 7 is. Web 7.0 is a unified software and hardware ecosystem. For building resilient, trusted, decentralized systems using decentralized identifiers, DIDComm agents, and verifiable credentials. And it has this tagline of take what you need, leave the rest, and I'll refer you to some of the other presentations to dive into that further. So what does the reference model for Web 7 look like? It just builds again on layer 0, layer 1, layer 2, layer 3, layer 4, and layer 5. So this is the 7th layer, layer 6. and we can see that it built on the mesh network model from layer 4. But here we had the virtual web drives as an example, whether that be Web 5, TBD Web 5, DWNs, solid pods, or Trinity graphs. Above the red line there, and then below the red line we can see that although we've been focusing on the DIDComm HTTP, DIDComm ARM HTTP profile, i.e. these blue circles, it's recognizing that DIDComm can run is transport agnostic and can run over whatever transport you'd like to use. So for example, DIDComm over Bluetooth, DIDComm over gRPC, WebSockets, P2P. Another element of 7.0, and it was talked about there in the elevator pitch, Web 7.0 is a unified software and hardware ecosystem. It's a multi-sided market. One side is the Web 7.0 software, or you could think of it as the decentralized operating system. On one side, there's this Web 7.0 always-on DIDComm agent appliance. It's a DIDComm agent appliance that would be paired with the trusted personal agent running on your phone. The trusted personal agent running on your phone would be a DIDComm user agent. It would be the apps that then talk to your DIDComm agent appliance. And this might be, for example, running in your home. Perhaps you keep it in a safe or a vault to protect the data on it. But the idea is that there is a hardware component. There's the decentralized operating system component. There's the hardware components, and then above and below the market are ISVs, independent software vendors, creating applications, DIDComm-based decentralized applications, and then below the marketplace would be just the services companies that are supporting the marketplace. But where do these layer 6 Web 7.0 live? Well, the always-on DIDComm agent is part of Trust Layer 4. You could almost think of it as foundational, but let's keep it with the agents. Let's keep it with the DIDComm agent, the DIDComm user agents, and keep the appliance up there. And then down at the bottom, I've re-highlighted the DIDComm agent mesh network, because now we're not only talking about the HTTP network, but any transport that you choose to run DIDComm on. And finally, there's the virtual web drives, the Web 5 DWNs, the solid pods, etc. So anything required to operationalize and complete the Web 7.0 architecture is in this layer. And that brings us to the end. So if you have any questions, you can send direct messages or Twitter posts to @FreddyArchitect, @FreddyArchitect on Twitter. And Freddy will be there to answer them. And with that, I'd like to thank everybody for attending and watching this presentation. Relatively short presentation at 30 minutes. And look forward to meeting with everybody and talking more about Web 7.0 and the 4-layer hourglass framework.